Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Today we're going to work on our backbone network. And we'll discuss, I'll show you the network design document here in a little bit. But for our test bed, it's just basically a wire. So we're adding a wire between the Cisco and the Juniper. And we'll look at that in the design document to see what that represents. For our test bed, it's just a wire though. But the main point of this video is we're going to look at some static routing. Okay? And static routing is probably the most used, I don't want to call it a protocol, but it's the most used routing I think I've ever used. So it's very important to understand static routing. And this is kind of, if you've been watching the videos, you kind of understand. So this is the kind of the Dallas office. It's on the 192.168.10 network. This is the New York office. It's on the 192.168.11 network, okay? And our trunk is going to be in the 172.16.0 network, okay? So we've got a couple things. We've got the trunk network, or the backbone network, if you will. Then we've got our office networks. And then we also have our management network up here. And I kind of drew this. This is my laptop that we'll look at when I'm doing the screen captures. And it's on the 192.168.1 network. And if you're wondering what this is right here, this is an old way to write an Ethernet switch. And it basically is two terminators on the end of it. And some of the old school network engineers will probably laugh at that. But anyway, so so my PC or my laptop is on this network. It's .156. This is using DHCP, so it changes randomly. And we need to make sure we can communicate with everything, right? So this network needs to talk to this network. This laptop needs to talk to both routers, which it does already, but also needs to talk to these networks and devices on these networks. So really the overview, what we're trying to do with static routing is we're trying to say, we tell the routers, say, okay, well, the 11 network, if you want to get to 11 network, you have to go that way, okay? If you want to get, and then when this, in the Juniper, you say, if you want to get to the 10 network, you got to go that way. And see, it's not obvious to the routers because there's a 172.16.0 network right in the middle. So you have to tell it, say, the 10 network is going this way. All right? And then also, you've got the laptop, and he needs to talk to these guys down here. And so we've got a default route in both these guys that we'll look at later that say, okay, well, if it's not going to the 11 network or the 10 network, it needs to go this way. And the same for the Juniper. It basically goes up that way. And by the way, this and this are the same network. I just drew them like that to make it easy. I didn't want a big, huge cloud. So that's about it. Let's get started. Okay, so first we're going to take a look at the backbone, the planned backbone network. So you probably saw this on a previous video. It looked quite a bit different than this, but it's basically the same. We got 3 routers, and they're going through a service provider, which is going to be a layer 2 VPN service. And this service provider is also going to provide our PSTN gateway and our World Wide Web access. So they're going to provide the access for these. And in the future, we'll we'll take a look at the architecture of the service provider. But for now, we're still working on our business network. Okay, so I've went ahead and fired up 3 SSH sessions. This top one is the Juniper router. The middle one is the Cisco router. And this bottom one here is our Ethernet switch for both routers. So, and I went ahead and did the show config and on all these and copied and pasted them and saved them, which I always recommend as a backup. So really all we're doing is I plugged a cable in here between these 2 ports. So we just got to change the IP addresses on these 2 ports to match our new network. And by the way, if you don't know how to read this, I put the network address and how large it is right here in the cloud, and it's for everybody. And then that way I just changed the last. Maybe I should just put an X here. Maybe that'd be easier to understand. Then I just changed the X out. So this is .1, this is .2, and this is the rest of the address. So you just add 172.16.0.2/24, etc. It just saves me from having to copy that over and over again. All right. So I guess we'll just start with the Juniper here. And let's see here, Juniper. So we're going to be renaming this guy. Rename. Interfaces. Gig. Oops. Big E. Unit 0. Family. INET. Address. This is going to be a long command. Let's see, I'll just copy and paste that. To address 172.16.0.2/24, I think. Let me double check our document here. Yep. All right. And we'll commit this. Okay, so that's that for the Juniper. Let's go to the Cisco now. Let's see, we're doing gig 01. So it's config T interface. I'm just going to copy this guy. And it's just IP address is 172.16.0.1/255.255.255.0. All right. And everything else can be the same. All right. And we'll go ahead and Control-C out of this guy and write his config. Okay, so I'll do a show int gig 0/1. This is layer 1 is up. Layer 2 is up. All right. So let's try. Well, let's do a show IP route, and let's see what we got here. Okay, so okay, so he sees. He's oh, this is our interface, right? And so he sees that this is directly connected, so we should be able to ping the other guy. 172.16.0.2. And yep. All right, very good. And let's go up here and let's ping them back. Ping 2.16.0.1. Yep. Excellent. Okay, so we were able to basically from this gateway, from the Dallas gateway, we're able to ping the the Juniper gateway, or the New York gateway, and basically we just ping this way. And it so happened to work. That could have actually failed, and it depends on where the from address is. I mean, that's all fine and dandy, but can I ping an 11.0? In other words, can I, from the Dallas router here, can I ping one of these 192.168.11 network addresses? And I'm probably not going to be able to, and I'll show you. So let's find, we'll just ping from the Dallas gateway to the New York gateway. We'll just try to ping 11.2, which is the IP address of the lag. Okay, so well, let's just start from the Juniper. So we know from the Juniper we can ping 192.168.11.2, right? Because he's local, right? No problem. But from Dallas, if we try it, ping 192.168.11.2, yep, see, he's going to fail. And if you're watching this video, you probably know why, because we don't have a route in the router telling them where 11.2 or 192.168.11 network lives. And there are several ways of accomplishing this. One, we can set a default gateway. So in other words, I can say, okay, I want anything not living here to go out this way, out this port right here. And that would be great, except I would lose my SSH connectivity into this, right? So that's not going to work. And be careful if you're ever doing this remotely. You can really really screw yourself if you screw up the routing and take your remote access down. Then you'll have to do a truck roll, which can be quite costly. Okay, so we're going to now there are no routes in this Juniper at all. Oh, and by the way, if you're wondering, we can go to the Juniper and try to ping the Cisco lag, which is, I believe, 10.2 somewhere. Yeah, 10.2. So if we go here and try to ping 192.168.10.2, yeah, he's not going to work. He doesn't know where he lives. Okay? So we'll just start from the Juniper side, and we'll just tell him. Say, okay, well, we'll do an edit. Okay, so the command is set routing options, and it's static route 192.168.10.0/24. All right, because we're telling it where this network lives, and it's next hop is going to be 172.16.0.1. And if you're kind of wondering about that, so I'm configuring this New York router, right? And I didn't tell it to use the .2 IP address, right? And that's because we've got to use the Dallas gateway IP address. If I tried to put .2 in here, he would probably reject it with an error, and because it's local, so it's basically, it would be like saying, well, send it back to yourself, if that makes any sense, right? We don't want it to send it. We want it to send it to .1, right? So that's why we say the next hop is the .1 for the Dallas gateway, right? All right, and we'll commit that. All right, and let's try to ping 192.168.10.2. 2. And it's working. Now I have to admit, I found that quite surprising. I actually expected that to fail. And here is why. Because, so when we send a ping packet from the Juniper to the Cisco, it says, okay, my to address is that 192.168.10.2. My from address, that's why so it used the from address of this gig interface right here, this gig E interface. That's why it knew how to route it back to the Juniper. So let me demonstrate. So if I do a ping, the same thing, 192.168.10.2. All right, and then we say the source. And by the way, if you've never done this, do a question mark. There's all kinds of ping options, and the Cisco's the same way. We'll do that here in a minute, but anyway, we'll want to use a source because we want to set the source address, and that's going to be 192.168.11.2, right? And now you can see it fails, and it's failing because the Cisco gateway, I'm sorry, the Cisco router doesn't know how to route back to that 11.2. That's why I couldn't ping it earlier. So now what we've got to do is we're going to go down into the Cisco and set it. And let's see, it's here's a default gateway right here, and we'll talk about that here in a minute, how to set the default gateways up. But okay, so we're on the Cisco router, so we're going to do a config T, and it's just IP route. It's 192.168.11.0, 255.255.255.0 to 172.16.0.2. All right, and I'm basically just saying, okay, that 11.0 network lives on the New York gateway. Okay, and look at that. As soon as I entered it, our pings immediately started working. See, now he knows how to route it back. So I'm going to do a Control-C and a write. We're going to save that. Okay, so now we should be able to ping both ways. So, and like I said, you can do the same thing with Cisco with the expanded commands on ping. It's ping, and then you hit enter. And protocol, when it's in the little brackets right here, that's its default. Okay. Now we do want IP. The target address is 192.168.11.2, and repeat count's fine. Is 5. Datagram size 100 is fine. Timeout in seconds 2 is fine. Now you want to say yes here at these extended commands, and here's where it's asking for the source interface, source address or interface. We're going to say it's 192.168.11.10.2. All right. Type server 0 is fine. DF bit, no, don't care. Validate reply data, no. Pattern, yep. And here we want verbose. Oops. And see, I changed it from none to verbose. This is kind of confusing for beginners sometimes. And sweep range. And that's it. That was pretty fast, wasn't it? Okay, so it sent packets with a source address of 10.2, which is our lag, and it was lickety split. So excellent. Okay, so let's take a look at our routing table in the Cisco, and it's show IP route. All right. And I'm going to expand this a little bit so we can take a better look at it. So you can read what all this means, but you can see right here this S is static, and this right here, this is our default gateway. That's this command over here. It's basically IP route 0.0.0.0.0.0. So this is the IP address. This is the subnet mask, and this is the default gateway. Now this happens to be out the management interface because that's how I'm going from this one network, this 1.1 network, and to SSH into this box, right? So basically I'm just saying route everything that you don't know what it is. In other words, this right here matches everything, right? And so it's basically saying just route everything out this interface. And now, if you look at our commands, if we do a show config, now you can see we have two routes in here. You might be kind of going, well, if this one is routing everything out this interface, why isn't it messing up this route? And the reason why is it's because the way the routing tables work in both routers actually is it goes from generalized routes to specific routes. The more specific a route is, it takes higher precedence over the general routes. Okay, so if I were to put a route in here, it said route 192.168.11.2 out of some other interface, and it would, of course, break. It would putting a 2 in here /32, which is kind of, well, that's right. That's just one IP address, right? That would take precedence over this right here, which is 255 IP addresses, and this right here, which is a couple billion. I don't know what it is actually. It's a lot. So so that's the way they work, and that's so every time he looks it up, he goes, okay, well, I can route them out this, but I found a more specific one, so I'm gonna use that one instead. All right. I hope that makes sense. So if we take a look at the Juniper, you'll notice it has no default gateway set up. I never did set it up, and that's because I'm coming from the 192.168.1.0 network, and that network is physically connected to gig 00. If we look at the routes in the Juniper, it's show routes. Show routes. Oh, show route. Sorry, I was putting S at the end of it. No wonder it wasn't working. Anyway, yeah, there's a lot of junk in here, and a lot of it's from, like, see, they got little headers right here saying that this is how the hardware is talking to each other. They're using these big old Class A network addresses, but that's okay. Let's see, where are we at? Okay, so here's local. So he says local, and here's our static that we added right here. Okay, but we have no default gateway set up, and like I was saying, it's because it knows this where this network address or this network lives is outside of FXP, which is a management port on the Juniper. Now, if I was in another part of the network, let's say the 192.168.2.0 network, he wouldn't know how to get to it. So we'd have to add a default gateway in there, and we might as well just go ahead and do that real quick. So let's do edit. And routing, oops, edit. Let me bring it up a little bit higher here. And we're going to say set routing options static route 0.0.0.0/0. Next hop is 192.168.1.1. Okay, and we'll commit that. Okay, so now if we look at our show route, I don't know why it's not show routes. That doesn't make any sense to me, but anyway. Okay, so here's our default. All right, and of course he's saying he's static and everything. And let's make sure our ping still works, shall we? There we go. Ping source. Yep. So see, it didn't affect, even though I said to route everything out the management interface, it didn't affect our the routing entry we added because it was more specific than our default route of all the zeros. Now the Cisco does have a default gateway. I never use it. And I don't know if there's a benefit to using it or not. I've never used it. So, yeah, if someone knows of a benefit that I'm not aware of using the default gateway command, let me know in the comments. Anyway, that's about it for this video. I was going to run the RFC 2544 testing, but I think I'll just split that off into another video. We'll keep this video short. Static routing is manual routing. Okay, so anyway, if you like this video, give it a big thumbs up. If you have any questions or comments, leave them in the comments below, and I will see you next time.